Welcome to the PortaCount Academy, and thank you for watching ResFit 101, Introduction to Quantitative Fit Testing. My name is John Morton. My email address is john.morton@tsi.com. If you have any questions on this course after watching it, please feel free to contact me for help. This course is designed to be a simple introduction to the basics of quantitative fit testing. I've broken the course down into 3 different parts. In the first part of the course, we're going to quickly touch on the basics of fit testing, and I will not go into too much detail here, as these courses are really designed to be focused on the operations of the PortaCount Pro Respirator Fit Tester. But we will briefly discuss who out there needs to be fit tested, and why that fit testing needs to be done, and how that fit testing needs to be done. In Part 2, we're going to talk more specifically about a method of quantitative fit testing, defining some of the terminology often heard in this regard, and step through the prescribed procedures. Now, in Part 3, we're going to talk about the technology used by the PortaCount Pro in order to perform accurate fit testing, and I'm going to discuss the differences between the 8038 PortaCount Pro Plus model and the 8030 PortaCount Pro model. As I said previously, we're going to start by doing a quick overview of general fit testing and what that entails. So what is the purpose or definition of respirator fit testing? Literally speaking, it's the practice of determining how well a particular respirator, a particular make, model, and size fits to a specific person's face. Now, I want to be clear here what respirator fit testing is not. It is not a test of the integrity of the respirator or the filter. It is quite literally testing how well the respirator seals to the face, specifically where it comes in contact with the skin to create a seal outlined here in red. Could a passing fit test be viewed as evidence of the mask's good integrity? To a point, yes. However, a failed fit test does not in the same way assume a poor integrity of the mask, as a failed fit test could obviously be derived from a poor fit instead. So who or which occupations might dictate the need for fit testing? Well, anybody who is required in their occupation at any time to wear a tight-fitting respirator should be fit tested in that respirator. This would include many occupations in the health and public services fields, doctors, nurses, police, firemen, and of course, various divisions of the military. There are obviously many occupations in the private sector as well, which would require fit testing. People who work with food processing, refineries, mines, hazardous waste removal, welding, asbestos removal. And in the upper right, we actually see a picture from the Gulf Coast where the oil cleanup took place. These cleanup workers would also have been fit tested before entering the contaminated work area. So why should we perform fit testing in the first place? Or how can we justify setting this time aside to confirm if the mask fits or not? First, I think most obvious reason is to ensure that the employees are safe. By fit testing the employee, we can know that the respirator is truly providing the respiratory protection that's needed. In addition to this, it can still instill confidence in the user that the respirator is going to protect them from their hazardous environment. The second benefit gained from fit testing is the training purpose involved. This is your time as the fit tester to ensure the employee knows how to properly don and doff the respirator and how it should feel to the employee when they actually need to wear it. Now, the third aspect is comfort, and I believe this is a topic that is too easily overlooked. We want to make sure that the respirator is comfortable to the employee, or as comfortable as they can be. If the respirator is not comfortable, the employee will not don the respirator properly when in the field, or worse, they may just remove it completely. And of course, always a good reason to perform our respirator fit testing is that OSHA, and in the case of Canadians, CSA, require it. In 2010, 2010 through 2011, OSHA issued over 95,000 safety-related citations. And coming in number 4 was respiratory protection, and it's been coming in at number 4 for many years previous. I briefly want to point out that fit testing is but one part of an entire respiratory protection program described by the OSHA standards. However, it is outside of TSI's purview to discuss other aspects of respiratory protection programs, so we're just going to focus on the fit testing aspect. As I said previously, a topic that is often overlooked during fit testing is employee comfort. So I want to take some time and address that directly. One part of the OSHA fit testing standard that I rarely see followed is that the employee being fit tested must don the mask for 5 minutes before the fit test begins. OSHA wants to do this for two reasons. First, it creates a bead of sweat where the mask comes in contact to the face. This bead of sweat helps to create a better seal and is a better representation of how the mask will be fitting in the field. The second reason is just to see if the employee can wear the mask for 5 minutes. If the mask is so uncomfortable it can't be worn for 5 minutes, then there's no reason to continue fit testing. Now, it is the responsibility of the employer to provide the option for different respirators if the employee finds the prescribed respirator too uncomfortable to perform their duties. And I would say that during that 5-minute user assessment comfort period, that is time that you can use to be describing the fit testing exercises to the employee. It is also time that you can use the real-time fit factor display function of the PortaCount to verify that that respirator is fitting, and that is discussed in other online webinars. So when are we required to perform this fit testing? Well, according to OSHA, we need to fit test the person before the employee ever enters the workplace or hazardous environment for the first time. I think that's pretty obvious. And then typically, we're going to do that on an annual basis thereafter. If you're following CSA, that's going to be biannually. We also need to fit test the person for each respirator they wear. Again, each fit test is according to one make, model, and size of respirator and one person. So if that person potentially wears 2 different respirators during their workday, then they need to be fit tested in both of those respirators. Also, if there are any notable changes in the employee's physical condition, such as facial scarring, dramatic changes in weight, etc., the rule of thumb is that if a person loses or gains at least 10% of their body weight, that person should really be fit tested again. So now we're going to move on to part 2, and we're going to discuss quantitative fit testing. Now first, just in case there's any confusion here, I want to differentiate the 2 different methods or kind of umbrella terms for fit testing. We're going to discuss the differences between qualitative fit testing versus quantitative fit testing. Now, qualitative fit testing consists of waiting for a response from the person being fit tested as to whether or not the mask fits. Often they're going to be responding to the tastes of Bitrex, which is a very bitter formula, or saccharin, a very sweet formula. And again, this would be a subjective test because we're waiting for a response. Quantitative fit testing is a method of taking a measurement aside from the person's response to determine if the mask fits or not. So we're measuring how well a specific make, model, and size of respirator fits to a specific person's face. And the key there is that it's a measurement. So it's an objective test, and therefore it is considered to be obviously a bit of a superior method. Now the results of quantitative fit testing is the calculation of a fit factor. It is this fit factor value which determines if the respirator fits or not. According to OSHA, the proper way to determine a fit factor is to take a measurement of some substance outside the mask and then compare that to a measurement of some substance from within the mask. The PortaCount accomplishes this by looking at the concentration of nanoparticles. Now we're going to define that better later on, nanoparticles. The fit factor, though, is quite simply a ratio. Concentration out divided by concentration in. So in the real world, this would mean that if you had a fit factor of 500, the air inside of the donned respirator is 500 times cleaner than the air outside of the donned respirator. Consequently, a fit factor of 1,000 would mean the air inside the respirator is 1,000 times cleaner than the air measured outside the respirator. But I want to take pause at this point and point out that we don't want you to draw the conclusion that therefore you need to achieve the highest possible fit factor you can, and that would mean that you are that much more protected. For example, I must be more protected if I have a fit factor of 20,000 than if I had a fit factor of 2,000. That's not the point. We really want to make sure that you achieve the minimum required fit factor set by your standards. For OSHA, that's 100 for half face and full face. Half face and filtering face pieces, and 500 for full face respirators. We just need to achieve the minimum. The fit factor difference between 10,000 and 20,000 and 30,000 is really minimal when you look at the protection that you're actually getting. Now here's an interesting tidbit of information. According to OSHA, just as I was saying previously, if you need to fit test a person using a fit factor greater than 100, and it is recommended that with quantitative fit testing the fit factor be 500, then you must use quantitative fit testing. You can't use qualitative methods like Bittrex, Saccharin, etc. to achieve fit factors greater than 100. So any qualitative fit test is by default only a fit factor of 100. Now the OSHA standard does say again that minimum fit factor for full face respirators should be 500. So all full face respirators should be fit tested using quantitative fit testing methods. There has been some confusion on this in the past, and OSHA does tend to sort of add to that confusion a little bit, but they have stated that qualitative fit testing can be done on full face respirators, and that is true. However, this doesn't supersede the rule and inherent truth that qualitative fit test methods can only calculate fit factors up to 100. So again, if you're using a full face respirator, it's more than likely you want a minimum fit factor of 500, and therefore you need to use quantitative. Now I have added this slide as a side note because I have found that there is sometimes some confusion about these two separate values when you get out in the field and you start fit testing. The assigned protection factor is determined by how the respirator is going to be used in the workplace. So for example, in this picture, the fireman will likely have backup filters and alarms on his belt. Obviously, he's got a self-contained breathing apparatus strapped to his back, and these are all going to be taken into account when calculating his assigned protection factor for that entire system. However, when the same fireman comes in for his annual fit testing, he's going to be wearing the same respirator, but he's simply going to have a P100 filter. Now, this mode of operation for the respirator is referred to as APR, or air purifying mode. It can also be called negative pressure mode. So all fit testing is done with the respirator in this mode of operation, which is how the fit factor is derived. So again, I just stress that assigned protection factor and fit factor are two different values, and they're not necessarily related. Now here's the prescribed steps to fit testing according to the OSHA standard. There are 14 steps in all, and the last step, 14, being the actual fit test. If you're following a different standard, I think that you'll find that though they may not be exactly matched up, the process is roughly the same no matter which standard you're referencing. The first step is pretty obvious. You're going to have to choose a respirator to wear. Step 2 is where you show the employee how to properly don and doff the respirator. This information should be obtained from the respirator manufacturer, and I would stress that teaching them how to properly doff the respirator is just as important as teaching them how to don the respirator. If they get claustrophobic during the fit test, we don't want them pulling out their hair trying to remove that respirator. Now step 3 is to ask if the person feels that the mask is comfortable. It feels like if it's is it a good fit? And then Step 4 is to try a different respirator if necessary. You could simply hold a respirator up to their face and kind of see if that maybe looks like it has a better fit rather than having them don and doff each and every one. Step 5, it sort of referenced earlier, the one most people forget to do, and that is to have the employee don the mask for 5 minutes before beginning the fit test. That's your user assessment comfort period. Okay. So step 6 is where we have the employee assess the comfort of that mask. Again, they're doing this during the user assessment comfort period. It's been donned for 5 minutes. And here's a kind of a list of what OSHA wants you to look for. Room to talk, room for any eye protection that's there, things like that. Now, step 7 is going to be similar to step 6, except it's more focused on you as the person performing the fit test to ensure that the mask appears to be properly fitted from your perspective. And I would note at this point that all fit testing should be done with a mirror. So you want to have a mirror available so that the person can see how that mask looks on their face when it's donned properly. And now step 8 is where the person being fit tested is going to perform a user seal check on the respirator. Now, I would personally not recommend that step 9 be done, I guess I said that wrong. I would personally recommend that step 9 be done prior to step 1. But in the OSHA standard, it's not written before there, but we want to make sure that the employee does not have any facial hair or jewelry, anything like that, that could interfere with the fit of the respirator. So anywhere where the elastic part of the respirator that fits to the face comes in contact with the face, there can be no facial hair, no jewelry, no obstructions. Step 10, again, should really be done under consideration during this entire process. Obviously, if the person is having difficulty breathing, then there may be some health issues that need to be addressed. Step 11, again, goes back to comfort, something that OSHA stresses as well. Even if the employee were to finish all 14 steps, including the fit test, and pass the fit test successfully, and in the end find that the mask is too uncomfortable to wear, then a new respirator and a new fit test are required. Step 12 is your opportunity to explain the fit testing exercises that they're to perform, and we're going to go over these in just a minute. And then step 13 is where the employee will want to wear any work-related gear that could potentially affect the fit. For example, if they wear a hard hat or a helmet during their occupation, then they should be fit tested with that equipment in place. And then step 14 is the actual fit test. So in reference to step 12, here are the fit testing exercises as required by OSHA when performing a fit test with the PortaCount system. There's 8 exercises in all. I believe most are pretty self-explanatory, but I would note that exercise 3 and 4, head side to side, head up and down, do not need to be done at whiplash speeds. Just a continuous and steady motion will suffice. So again, normal breathing, straightforward normal breathing. Deep breathing, you should see the person's stomach moving in and out, signifying that they're actually breathing deeply. Turning head side to side, they should turn their head, look over their right shoulder, and take a breath. Turn their head, look over their left shoulder, take a breath, and do that back and forth. Moving head up and down, they should look up at the ceiling, take a breath, look down at the floor, take a breath, and do that motion back and forth. Again, does not have to be done at whiplash speeds. Talking, there is a section in the back of the manual called the Rainbow Passage that is recommended to talk, basically read through that Rainbow Passage. If you complete the Rainbow Passage, you should start over because you should be talking the entire exercise. And you should only talk during the talking exercise and not talk during any of the other exercises. Again, the Rainbow Passage is provided in the back of the PortaCount Pro manual, but if it is not required to read that, you could have them count backwards from 100, you could have them do the alphabet, The whole point here is to just be talking. Now I would also note, again, bending over, stand up, take a breath, bend over, take a breath, stand up, take a breath, normal breathing, back to normal breathing. I'm going to talk about Grimace on the next slide here, so I'm going to get to that in just a second. And I'm also going to note that OSHA does require a person to be standing during a fit test. Okay, they should not be seated at any point. They need to be standing. And I also want to cover that OSHA is only concerned with the overall fit factor, not the fit factor for each and every exercise. One could potentially fail 1 or 2 exercises and still pass the overall fit test. Okay, so now that Grimace exercise, which I kind of skipped over there, and the Grimace is only in the OSHA standard. If you're following a different standard, you're not going to have this exercise. The Grimace is the only exercise that should not be calculated into the overall fit factor. Now the reason why is the whole point of this exercise is to try to break the seal of the mask by contorting the face with either a smile or a frown. Now this test only takes 15 seconds, and the other ones at this point take 60 seconds. Again, the reason is we're not looking to calculate a fit factor, we're looking to momentarily break the seal. Now the idea is that in the workplace it's not uncommon to momentarily break the seal of the respirator. OSHA is concerned with whether or not it reseats properly afterwards for those last 2 exercises. Now before we move on to part 3, I just want to take some time here and discuss the other protocols other than OSHA, CSA out of Canada, HSE out of the UK, and ANSI. They all have roughly the same protocol, 7 exercises, basically minus the Grimace. They are also only concerned with the overall fit factor, except for HSE. HSE does require that every exercise have a passing fit factor. Okay, now we'll move on to PortaCount Pro Fit Testing, Part 3, which is really a discussion on the science behind the PortaCount. How does the PortaCount accomplish what it does? As I mentioned earlier, the PortaCount determines fit factors by measuring nanoparticle concentrations outside and inside the donned respirator. Now, whether I say particle concentration, ambient aerosol, particle counts, whatever, I'm talking about the same thing. I'm referring to how many particles are found in a cubic centimeter of air. Particles are created primarily by us. We're kind of sloughing off skin particles and we're adding to the ambient aerosol. Now to give you an idea of just how small the particles of the PortaCount reads, we have a picture here in the lower left. Now the average human hair is roughly 70 microns in diameter, and here we kind of break it down into smaller and smaller and smaller particles in relation to that human hair. Now the PortaCount goes even smaller. It looks at particles that are between 0.02 and 1 micron. So very, very small particles, and by definition, nanoparticles. Now here's an example of the average size ranges of certain common ambient particles. And here's an example of the types of particles that are going to be found in the size range that the PortaCount is looking for. For example, you got diesel exhaust, tobacco smoke, those kinds of things fall into that range. Now how the PortaCount counts these particles is through a technique called condensation particle counting, also CPC for short. In essence, the PortaCount is a CPC that can calculate fit factors. Now here's a better example of what a CPC is, or what the PortaCount does during a fit test. The particles are sucked into the PortaCount and mixed with alcohol vapors from the alcohol cartridge. When they pass through that mixture, we bring that into a condensing chamber. Basically a chamber that is kept at a slightly cooler temperature so that those alcohol vapors actually condense onto the particles. When this happens, the particles grow in size. And then we can count them by passing them through a laser beam and measuring the light reflected by the particles. We need to grow the particles because particles in the size range that we want to look at are so small that they're too small in their original state to reflect enough light to be seen. Now here's the same detailed diagram, this obviously more detail, as to what is happening during a PortaCount fit test. But the same 4 steps that we saw just previously. We pull the air in to be sampled through the PortaCount, mix that sample with alcohol vapors, condense the alcohol vapors onto the particles so those particles grow in size, and then pass those particles through a laser to count them. So we have 2 models of the PortaCount. The first model is the 8038 PortaCount Pro Plus. Now this model has the option of fit testing full-face respirators, half-face masks, respirators, along with being able to fit test filtering face pieces, specifically those face pieces that are rated at 95% efficient or less than 99% efficient. So why do we have, the second model is the 8030 PortaCount Pro. This model can only fit test full-face respirators and half-face respirators. So the difference here is that it cannot fit test filtering face pieces that are less than 99% efficient. So why do we have these designated differences? Okay, it's all in the filter efficiency. Okay, if the filter is less efficient, less than 99%, then we need to employ an N95 companion, which is a piece of equipment internal to the 8038 models. So we're going to take a small detour here in the next couple of slides, and I'm going to fill you in on some background information which will help you to clarify why we have a difference between an N95 fit test and a fit test on a full face or half face or 100% efficient mask. So let's take a moment and define some of the terms commonly heard when discussing filters. First off, efficiency. This is referring to how many particles are removed by the filter media. So in the U.S., we use our filter efficiencies as 100, 99, and 95. And those numbers literally mean what the efficiency is. So 100%, 99%, and 95% respectively. And penetration is how many particles are expected to get through the filter media. And we're going to find out in a second here that this efficiency is rated at one particular size range of particles. It's not the whole spectrum. It's one particular size range. And the leak is what we are most concerned with. This is how many particles get around the face seal of the mask. So when we compare an N95 face piece to a half mask using a 100% efficient filter, we know that the filter face piece is simply less efficient. More particles will penetrate that filter media in a specific size range. So let's take a moment to clarify how filters actually work. How do they actually filter out these particles? Okay, well imagine the red line seen here is the airstream, and the yellow circles are the cross-section of the filter's media fiber. Now there are 4 different methods for a filter to grab particles out of the airstream. The first method of filtration is called impaction. This occurs when particles are larger than 0.4 microns. In this case, the particle's inertia causes it to break free of the airstream and literally impact on the filter media. The second method is interception. This occurs when particles in all size ranges. Simply means that the particles got caught passing by or were intercepted in flight by the filter media. The third method of filtration is called diffusion. This occurs only to particles smaller than 0.1 micron. Basically, these particles in this size range are so small that they're pushed around randomly by the air molecules, and they eventually end up landing on the filter media. The fourth and final filtration mechanism is called electrostatic attraction. This is a fairly new method, doesn't exist on all respirators, but the idea here is that by placing a small electrical charge on the respirator, obviously not one strong enough for anyone to feel, particles of an opposite charge will be attracted to the filter media and removed from the airstream. Now, if you'll remember from the last slide, we had particles greater than 0.4 microns being removed through impaction and particles smaller than 0.1 micron being removed through diffusion. But that leaves particles between those ranges that aren't really affected by either of those. So these particles will be much more likely to penetrate the filter media. Okay, and this goes for all particle filters. This isn't just specific to respirator filters. This is true of all particle filters. Now the graph here shows the efficiency of filtration. We've got it listed from 90% up to 100%, and the line that you're looking at is the filter efficiency curve of a 95% efficient mask. You can see that at its lowest point, it is right about 95% efficient. But what I want you to notice is that right when you get down to 0.1 micron, the efficiency of this N95 mask is almost 99% efficient, and within no time, we're at 100% efficient. Same as what happens when we go above 0.4. When we're above 0.4, we're almost 99% efficient again. And particles greater than 0.4, they're going to be filtered out with almost 100% efficiency. So where it's 95% efficient is between this 0.1 and 0.4 microns. Again, the particles that are going to manage to penetrate the filter media, especially on filters that are less than 99% efficient, are these particles highlighted here in this size range. So now we're going to all bring this back to the PortaCount. Okay, we're off the tangent. We're going to come back. And why is there this difference between the 8030 and the 8038? What makes the N95 companion different? So as you can see here near the bottom, there's a vast array of particle sizes in the ambient air. And as I said earlier, the PortaCount looks at particles between 0.02 and 1 micron. So when the N95 is enabled, the PortaCount Pro Plus only sees a small fraction of the same particles, looking at particles that are roughly between 0.03 and 0.08 microns. So since we're looking at a much smaller range of particles, we can expect to see a much smaller concentration of particles. This is something you'll notice if you happen to fit test both 100% efficient respirators and 95% efficient respirators. You'll notice that the particle counts are very different. Now the reason we're looking at this much smaller size range is that we want to ignore or remove that most penetrating particle size range that we just talked about in the last slide, that 0.1 to 0.4 micron. Since those particles will likely penetrate the filter media, if the PortaCount were to see them during a fit test, it would appear as though the face seal was leaking. So by focusing only on the smaller range of particles, we know that will be filtered out, then we can see these particles. We know they came in through the face seal leak, which is these are the particles we want to test for. Again, the particles that are in that most penetrating particle size range, we want to ignore those. And by measuring only the smaller particles, if we see them at the PortaCount, we know they came in through the face seal leak, because even an N95 mask should be about 100% efficient at that size range. I know that's a long-winded explanation of why we have the N95 companion, but it does take some detail to explain what the purpose is there. So in summary, all employees who are required to wear tight-fitting respirators should be fit tested according to the procedures I described in Part 1 and 2. And of course, I always recommend that you reference your fit testing standard. We also discussed the difference between qualitative and quantitative fit testing and how the PortaCount, a method of quantitative fit testing, uses typical ambient aerosol to challenge the mask and make sure that respirator is fitting properly. And then we went over the differences between the 8030 and the 8038 PortaCount Pro models and why that N95 companion or that N95 enabled option makes such a difference. If you have any future questions on these or other topics, obviously anything related to the PortaCount Pro Respirator Fit Tester or the FitPro Fit Test software, here's some helpful links for you to have. Again, these webinars are available for download from our PortaCount Academy online training center. I want to thank everybody for watching, and again, if you have any questions, you can use the websites here, or you can email me at john.morton@tsi.com. Thank you.